Hi everyone, it's Miss Berry again. I'm just making a quick video here to help you with some of the tough questions from the homework on section 5.3, or excuse me, on section 5.2. So in this problem, we're looking at a binomial problem, and instead of asking you to find the probability that it is equal to a value or the probability that it's less than or equal to a value, it frames it as a greater than problem. So I'm going to show you how to do those. So I'm going to share my screen. Okay. All right. So it says a real estate agent has 18 properties that she shows. She feels that there is a 50% chance of selling any one property during a week. Okay. So the chance of selling any one property is independent of selling another property. Compute the probability of selling more than 5 properties in a week. All right. So we've got a couple of things here that tell me that this is binomial. We've got a total of 18 houses or properties that she's selling. So that's our number of trials. Trials. Every house is a trial. The probability of selling a property is given to you in this problem. So the probability of success P is equal to 0.50, 50% in its decimal form. The trials are independent, right? And then I can either sell the house or I don't sell the house. So that means it's a success or failure situation. So all of that combined tells me that this is a binomial problem. And I'm supposed to find the probability, and we'll just use X here to be the number of houses that she sells. So let's see if I can throw that in here somewhere. X is going to be number of houses she sells. Okay, so we're looking for the probability that she sells more than 5. So that would be X is greater than 5. Okay, so I have this big table built in here to try to help you like get an idea of how we're going to adjust this probability to something that we can calculate. All right, so this is going to be X and then the probability of X. All right, so she can sell 0 houses, 1 house, 2 house, 3 2 house, 2 houses, 3 houses, all the way to 18. That'll be her maximum number of houses she could sell in a week. And this is all theoretical. You know, I don't know how many houses a person could actually sell in a week, but we're going to assume that it's possible that she could sell all 18. All right, so let's think about what these probabilities represent. This first one here, this would be the probability that she has the 18 properties that she shows. So she shows 18 properties, but she sells 0. This is the probability of showing 18 houses and selling exactly 1. This is the probability of showing 18 houses and finding exactly 2, exactly 3, exactly 4, and so on. Okay. So something that we know about probability distributions is that all probabilities must add to equal 1. Right, so all the probabilities in a sample space have to sum to exactly 1. All right, so we're supposed to be finding the probability that she sells more than 5. That would be the probability that she sells 6, 7, 8. Actually, let me highlight those instead of drawing in them. Just going to highlight those squares instead of drawing inside of them. Highlighter. Okay. So more than 5, that would be all of these. So this would be the probability that she sells more than 5. She could sell 6, 7, 8, 9, 10, all the way to 18. All right, so you know that our calculator can only handle problems of 2 different types. All right, so our calculator can only handle the equal to problems, that's binom PDF, or the less than or equal to problems, that's binom CDF. All right, so you've got to reframe this problem as a equal to problem or as a less than or equal to problem. And there's a couple of ways that you could accomplish this. Some of them are easier than others. One way that you could do this, if you wanted to use binom PDFs, so if you just wanted to go in and do a bunch of equal to calculations, then you could go in and find each one of these little boxes. You could find the probability that x was equal to 0, and then add that to the probability that x is equal to 1. Add that to the probability that x is equal to 2, all the way to 5. Now, how would that help you? Because if you knew what this amount was, you know that this amount, the amount that's in red plus the yellow, has to add to equal 1. So if you can find the amount that's in red here, then we can just subtract that from 1 to figure out what the yellow part is. All right, so you can do this. You can do a bunch of binom PDFs, but the faster way, and the way that you would only have to do one, you would only have to plug stuff in your calculator one time instead of having to do it for each individual, for 0, for 1, for 2, for 3, all the way to 5, is you could say, okay, well, this red part, this is the probability that x is less than or equal to 5. All right, so I'm going to find that. That's going to be binom CDF. This is not going to be my answer, but it's going to help me find my answer. All right, so remember it's n comma p comma x. N is the number of trials, that's 18. Gosh, that was a terrible 8. All right, 18. P is the probability of success, that's 0.5. And x is our x value, that's right here, that's 5. All right, so let's grab our calculator. I'm going to clear that out. Clear this out, start with a blank slate. Okay, so we're going to go to second vars, scroll way down to binom CDF. There it was. Trials, we said she has 18 houses she's selling, 50% chance of selling each one. X value was 5. Right, so go down to paste, hit enter again once you verify that that all looks correct. All right, so this is telling us that this red portion of our table is 0.0481. All right, so the red portion of our table sums to 0.0481. All right, so now we know what the red part is. So 0.0481 plus the yellow highlighted part equals 1. All right, so now we're just going to go in here and subtract 0.0481 both sides to get yellow by itself. All right, so 1 minus 0.0481, 0.9519. All right, so that tells me that this yellow portion is I've already forgot, 0.9519. All right, so the probability that x is greater than 5 is 0.9. I feel like I said that wrong. No, I did. 0.9519. My goodness. There's our answer. Sorry, it's so messy. All right, so hopefully that helps you with the greater than problems. You have to just reframe them in your mind and think, okay, I can build this probability distribution, which is this table here. And so if I'm trying to find the probability that's greater than 5, that's the opposite of finding that it's less than or equal to 5. So if you find that, you can subtract it from 1. and then find the probability. All right, guys, hopefully that helps you with this problem. Sorry for the jump scare, jumping back on your screen here. So hopefully that helps you with the problem, and I hope if you have any other questions that you'll let me know. I'm happy to make any additional little quick videos to help you with the homework. All right, I'll see y'all next time.